Application of linear and quadratic equation to capital markets. Example 1. In an election, there were 3 candidates. 3/7 of the electors voted for the winner. The runner-up received 5/8 of the remaining votes. A. What fraction of the electors voted for the third candidate? B. If the winner received 3,021 votes, more than the runner-up, how many electors voted? So if you look at this question very well, it is the application of linear and quadratic equation to capital markets. Here we have A, B, and C as the 3 candidates. Let A, B, and C be the 3 candidates. 3/7 of the electors voted for the winner. Let's say, let A be the winner. Let's assume that A is the winner. So A will definitely be, let the total electors be X. So A will definitely be 3/7 of X, and that will definitely give us 3x/7. That is for the winner. The runner-up received 5/8 of the remaining votes. How do you calculate the remaining votes? Remaining votes will definitely be total minus A. That's the one for the winner. So what is the total? X minus the one for the winner. That's 3x/7, and that will definitely give us 7. That's 7x minus 3x, and that will definitely be 4x/7. So this is the remaining. So the B, let's B be the runner-up. So the B is 5/8 of the remaining. So 5/8 of 4x/7, which is the same thing as saying 5/8 times 4x/7. 4 here 1, 4 here 2. So then this one will give us 5x/14. So that will be the runner-up. Then, what fraction of the electors voted for the third candidate? Number of electors, the total number of electors should definitely be for the first candidate plus the second candidate plus the third candidate, which is C. Then, X, for A, you have 3x/7. Plus for B, we have 5x/14. Plus C. C is the third candidate. So if you want to know the fraction of the third candidate, all we need to do is to transfer this to this other side, and we make the C the subject of the formula. So when we make the C the subject of the formula, when you have this one comes to you have x minus 3x/7 minus 5x/14. Let this one be also be fraction. What's the SCM here? 14. How many 1 will you see in 14? 14 times x, 14x. Minus, how many 7 will you see here? 2. 2 times 3x. That's 6x. Then how many 14 will you see here? 1. 1 times this minus 5. So 14x minus 6x, that will give us 8x. 8x minus 5, that's 3x. So therefore, C will be 3x/14. So therefore, the fraction for the third candidate candidate, which is C now, is going to be 3/14. That would definitely be 3/14. That's the answer to question in example 1, the A part. If the winner received 3,021 votes, more than the runner-up, how many electors voted? Winner, A. Winner is A. The runner-up, that is B. Runner-up, that is B. What is the fraction of the winner? 3x/7. What is the fraction of the runner-up? The fraction of the runner-up is 5x/14. That's the fraction of the runner-up. Then the question says that the winner received 3,021 votes more than the runner-up. What it simply means is that A minus B will be equal to 3,021 votes. So automatically, what is our A? Which is 3x/7 minus B, 5x/14 is equivalent to 3,021 votes. So what we do here is to look for the LCM here, 14. 7 in 14, 2. 2 times 3x, 6x. 14 is 1. 1 times this minus 5x, which is equal to 3,021. So 6x minus 5x, that gives us x/14 equals to 3,021. So what we do here is to cross multiply. So x will definitely be 14 times 3,021. So the total number of electors that you have there will be 14 times 3,021, and that would definitely be 42,294. So x will be 42,294. Therefore, the total number of electors will then be equal to 42,294. So that means the total number of electors will be 42,294. How many electors voted? The number of electors that voted will be 42,294. Surface area and volume of sphere. Now, the surface, this is a sphere. It's like a circle, but it is not really a circle. Your orange is an example of a sphere. So when we talk about the surface area of a sphere is 4 pi r squared. That's the formula for calculating the surface area of a sphere. We're talking about sphere. Then the volume is equal to 4/3 pi r cube. So this is the surface area and this is the volume. So we have a hemisphere too. Hemisphere. So when we talk about hemisphere is definitely talking about half of a sphere. So this one is known as hemisphere. So if you are asked to calculate the volume, the surface area of hemisphere is more or less like saying surface area will definitely be half of the surface area of a sphere. So half of it will now be 4 pi r squared divided by 2, and that will give us 2 pi r squared. So that is the surface area of hemisphere. So we can be asked to calculate the curved surface of the curved area. The curved area and the curved area here will definitely be pi r square. The curved area will definitely be pi r square. So if you have this, we're talking about the curved area, which will definitely be, you have the curved area this. So automatically, if you want to talk about this total surface area, which is 4 pi r square, and I said the surface area of the hemisphere would definitely be half of the surface area of the sphere. And since the surface area of the sphere is 4 pi r square, you divide it by 2. Then another thing to calculate is the curved surface area. I think the curved surface area is also 2 pi r square. That is the formula for also the curved surface area is also the same thing as the surface area. Then now, if you ask to calculate the total surface area, total surface area will definitely be curved surface area plus area of the lid, and the area of the lid is pi r square. So automatically curved surface area, which is 2 pi r square plus pi r square, which is the area of the lid. Because when you cut this now, this here is the lid, which is also acting like is also a circle. And what's the area of a circle? That is pi r square. So automatically everything becomes 3 pi r